All right, today we are going to be working on part 2 of the January 2016 Geometry Regions exam. This is not the Common Core version. So, January 2016 Geometry Regions exam. All right, first question, number 29. First question in part 2. The sides of a triangle measure 7, 4, and 9. If the longest side of a similar triangle measures 36, determine and state the length of the shortest side of this triangle. Pause the video, take a moment to try it by yourself before I give you a hint. All right, here's the hint. First, I'm always going to draw out what I need. So, for this hint, I will draw out two triangles. I'll draw out first a smaller one with side lengths 4, 7, and 9, and then I'll draw a similar triangle. Since it says the longest side of my similar triangle is 36, this whole triangle is going to be quite a bit bigger. Now, the longest side on my small triangle is 9, so that means the longest side on my similar large triangle is going to be in that same spot, and I'll label that with 36 now. Pause the video again and see if you can solve it from here now. All right, at this point, we're going to go over the entire question together. There are two ways that you can solve this. I'll show both of them. Why not? So, first way you can think of it is as if I have a triangle and a similar triangle, there's some scale factor I can multiply all of these sides here to get to the sides there. I know that to go from 9 to 36, I'm going to have to multiply by 4, because 9 times 4 gets me 36. Well, I've got my scale factor that's equal to 4. So then I can just multiply each of these sides by 4 as well, and that'll find the missing side lengths. So here, I've got 4 times 4 is 16. Here I've got 7 times 4 is 28. Well, they're looking for the shortest side of this triangle. I just found it. It's 16. If you want to do it a different way, I'll just redraw these really quickly. I can have 4, 7, 9, and then, ooh, that one's gross. Then I can have 36 and x here. I know this is the side I'm looking for because the corresponding side is the smallest here. I can just set up a fraction here. I can say 9 over 36, the two corresponding sides here, is equal to the fraction with the two corresponding sides here. Make sure if I put the smaller one on top to start, I'm sticking with the smaller one on top here. So that's equal to 4 over x. If I start to simplify for this, I get, by cross multiplying that is, I get 9x is equal to 4 times 36. 30 times 4 is 120. 4 times 6 is 24. 120 plus 24 should be 144 is equal to 9x. I'll divide both sides by 9 to get that x is equal to, I can use my calculator for this, I believe it is 16. X is 16. That's exactly what we found there. We can be sure that we got this question correct. Next, we're going to move on to question number 30. Again, I'll read the question, and then we'll give you a hint before you go on to finish it yourself. All right, let's focus camera. Here we go. Triangle ABC has coordinates 6, -4, 0, 2, and 6, 2. On the set of axes below, graph and label triangle A', B', C', the image of triangle ABC, after a dilation of 1/2. Pause the video now to try it yourself, and then I'll come back with a hint. Okay, so there's not much to hint at here, so all I'll do is I'll just get started by plotting those points correctly, and then reminding you that a dilation means that I'm changing the size of my shape using this scale factor. So I'll start by plotting, and then I'll give you another moment to try it. So A is at 6, -4, B is at 0, 2, so this is A, B is up here, and C is at 6, 2. This is C. Now that I've drawn that out and reminded you that dilation is just a change in size by using the scale factor they give you. Try and take another moment to solve it on your own now. Okay, at this point, let's finish up this question together. So, my dilation's 1/2. If it doesn't tell me a center, I'll assume that my center is at the origin. So I started 2 away from the origin here, 2 away. Because I started out 2 away, I want to be now half as far away, so my new point is going to be 1, because 1 is 1/2 of 2. And this will be my B prime. Next, I'm going to count out, all right, how far away is C from my center of dilation? It is 1, 2, 3, 4, 5, 6 away, and then 2 up. Well, now instead it's going to be half that distance. So if I was 6 up, 6 to the right, and 2 up, times 1/2 times 1/2. Now I'm going to be 3 to the right, and just 1 up. So I'm going to go 1, 2, 3 to the right, and 1 up. This will be my C prime. And then finally, I'm going to do that same thing for A. 6 to the right, and 1, 2, 3, 4 down, which means now I'm going to be half that distance, which is, again, just 3 to the right, and this time I was 4 down. I'm going to be half as much. I'll just be 1, 2 down. This will be my A prime, and that is the finished answer for this. Make sure that you're drawing out A prime, B prime, and C prime on it. I've got a bigger image over here of that step, of that process. All right, moving on to the next question, number 31. So, number 31, I've got in parallelogram. Let's focus this camera. Come on, come on, come on. In parallelogram, RSTU, the measure of angle R equals 5x minus 2, and the measure of angle S equals 3x plus 10. Determine and state the value of x. Pause the video here, take a moment to solve it by yourself before I give you that first hint, which you might have already seen a little bit of. Okay, at this point, let's take a look at the first hint. Always, always, always start out by drawing your diagram. So I've got my parallelogram, RSTU, and in here, I'll put in the measures they gave me. They gave me that angle R was 5x minus 2. That was its measure. And the measure of angle S was 3x plus 10. The big hint here is that in my parallelogram, I extended these two lines with the red lines here, and I made a transversal. Now try to solve this problem on your own. Okay, at this point, let's finish solving it together. Since I have a transversal, what do I know about the sides over here compared to the sides over here? Well, I know that this side, this angle here is equal to its opposite angle, and also that the corresponding angles in this part match up to their angles over here. So that means that this angle over here is also 2 hash marks, and since this angle over here is 1, that means its vertical angle is 1, and the corresponding sides on this part of the transversal are also 1 hash mark. Well, hey, so I've got that the 2 hash marks is 5x minus 2. I can write that in 5x minus 2 over here. I've got 3x plus 10 and 5x minus 2. Together, they join up to make a full straight line. Well, I know then that these two angles are going to add to equal 180. So let's set up this equation. I've got 3x plus 10 plus 5x minus 2 is equal to, they're supplementary. They make a straight line, 180. Now it's just an algebra question. I'll go about doing this whole one, though, just to practice a little bit. So I've got my like terms, 3x and 5x here. That means I've got 8x, and then these like terms, plus 10 and minus 2. Plus 10 minus 2 gives me minus 8 is equal to 180. I keep solving for x. Sorry, this is plus 8 because it was plus 10 minus 2, so that's plus 8. Now I'll take away 8 from both sides to get this x by itself. I'm going to run out of space. Maybe I'll make it just barely. So now I've got 8x is equal to 172. I'll divide both sides by 8, and I find that x is equal to 172 divided by 8, which should be 21.5. And that's your answer. Make sure to box it so that they know where to look. And that's all. All they're asking is for you to determine and state the value of x, which we've got right here. All right, moving on. Question 32. 32. Determine and state the length of a line segment whose endpoints are 6, 4, and -9, -4. So if you want, you can use the distance formula, but I hate the distance formula. So I'm going to show you a different way about how to go around answering this question. First, I almost forgot. Take a moment to try and solve it yourself, and then I'll give you a hint. Okay, I already gave the hint before that you could use the distance formula, but here's the way that I like to solve this problem, because I can't memorize the distance formula. First, what I'm going to do is draw out on my paper just a coordinate grid. Just like that. Let me have this go a long way because I'm going all the way to -9, -4. And I'll plot my 2 points. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. I've got the point 6, 4 right over here. And now I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, -9, -1, 2, 3, 4. I've got the point -9, -4 right here. I've just plotted the two of them. Now my hint that I'm going to give you before I show the entire answer is I can't measure the units diagonally. But if I draw out a horizontal and vertical line from each of these points, so I'll draw a vertical line from this one going really far, and then I'll draw a horizontal line from this one. Well, if you notice right here where these two guys intersect, it makes a right angle. And if I look at this shape as one shape right over here, I've got a right triangle. That should help you find that distance. Take a moment to solve this on your own before we finish this question in total. Okay, at this point, we've got a right angle, a length that I want to know, and 2 lengths that I can just count out. I'm at -9 over here, and I'm going to go, how far is this distance going to be? Well, I'm at -9. I'm going up to +6. I can count 9 across this way, and then 6 more here. This side is of length 15. Similarly, I've got, all right, I'm 4 up, so it's going to be 4 there, and 4 below the x-axis, so it's 4 there. This side over here is 8. I've got a right triangle, and I was given both of the sides. Now all I need to do is just find that missing distance. So let's use the Pythagorean theorem. A squared plus b squared equals c squared. My hypotenuse is what I'm missing. I'll just plug these two in. I've got 8 squared plus 15 squared is equal to c squared. 8 squared is 64. 15 squared, I'll just plug that in to get that real quick. 15 squared is 225. 225, and that's equal to c squared. Now I'm just going to add these two up. This is going to be 289, I believe. 289 is equal to c squared. If I find the square root of both sides, that's going to give me my length here. So I've got the square root of 289 is equal to c. Square root of 289. Let's plug that into the calculator. Square root of 289. I found that to be, sorry, not 19, 17. And that should be our answer right here. Now, if you want to be really careful, just to make sure that the scorers know what you're talking about, you can say the length of the line is 17 units, period. Maybe I should start this with a capital T, but it's too late now. All right, I think we're getting on to our last question in part 2. Oh, 2 more. All right, let's keep going. All right, the base of a right pentagonal prism has an area of 20 square inches. If the prism has an altitude, that means height, of 8 inches, determine and state the volume of the prism in cubic inches. Take a moment, first pause the video, try to solve this question on your own before I start with a hint. Okay, so you don't really need to draw out this whole one because a pentagonal prism is kind of hard to draw. But I'll just draw it as they explain. So I've got, all right, pentagonal prism means I've got a pentagon, so 5 sides, 1, 2, 3, 4, 5. I know that this is my base and it has an area. The area is equal to 20. And it's a prism, so it's 3 dimensions, and I can draw it out like that. And I'll finish the sides over here. I know that the area of the base is 20, and that the altitude, or just the height of it, is 8. So this is 20 inches squared. This is 8 inches. Well, all you need to do at this point is remember your reference sheet, which I should have in the back right here, which gives me the volume of a regular prism. Here they just give you the volume of a cylinder, but really the volume of any regular prism is always going to be this. The volume is equal to my big B area of my base times my height. So big B area of my base times my height. Now try to find this question out on your own before we finish solving it together. So again, they gave us that the base area of my prism, even if you don't remember what pentagonal prism means, just the base of my prism has an area of 20 square inches. The prism has an altitude, which just means height, of 8 inches, and I just need to determine the volume of this. Well, this is your big volume formula right here. For just a regular prism, which means it's not getting bigger or smaller as it goes along, it's just staying regular, I've always got that my volume is equal to the big B times the little h. Big B means the area of my base, and h means the height. Okay, well, they gave me the area of my base was 20, the height of it, the altitude was 8. That's the entire question. So 8 times 2 is 16, add a 0. This should be, the volume is going to be 160 inches cubed, because I had inches squared here times inches. So inches squared times inches gives me inches cubed. And let me just make sure that 20 times 8 is 160. 20 times 8, 20 times 8, 160. Nice job. Final question. All right, using a compass and straight edge, construct the bisector of angle CDE. Construct the bisector of angle CDE. This is a real throwback, this one. Well, take a moment to try and solve it by yourself, and then I'll start you out with a hint. Okay, for the hint of this one, first thing I'm going to tell you is just that first step you're going to take. To draw a bisector, your first step is going to be just drawing a circle, any size circle, centered at the vertex of your angle. I'll try to do this, but the page is kind of not flat. So I'm just going to draw a circle centered around my angle right there. Even that is enough of a circle. With that first step, see if you can remember the next two steps. All right, let's finish up this question together. I've got, my first step was to draw a circle around here. The next step is I'm going to draw a circle with center right where I intersected over here and radius going to that second intersection. So I'll draw a circle centered over here, and the radius is going to match up with that point over there. So I'm centering it on the first intersection, and the radius is going to be the distance from this point to that second intersection. And I'll do my best to draw out part of that circle. So here we go. Drawing out the circle to the best of my ability. There. And then next, the final part is I'm just going to draw another semicircle centered here with radius going from here to over here. So I'm just flipping where I have my center this time. And trying my best to draw out that circle again. Shoot, looks like the page is getting in the way. All right, so I drew the circle to the best of my ability. Where those two circles intersect, that's where I'm going to draw out my angle bisector. And if I did everything right, I should have created a line that cuts my angle directly in half. Now, if it's not exactly perfect, that's okay, as long as you show and make sure you do not erase your drawings of the circle. Leave all construction marks. All right, that is part 2 of the January 2016 Geometry Regular Regions exam. I hope that this was helpful.